Again, what we're gonna do, if we add the elements this way, right? Keep adding to the bottom and remove from the front. Whenever we move this pointer to the next one. That is going to be a Q-Day structure, right? Because Q saying that first in, first out, right? Because 3 happen to be the first one that in. When I remove, I just move my pointer to point to 4, right? And this whole thing, you don't have to worry. When I say whole thing, meaning the pointer here and 3 itself, you don't have to worry. When you remove, okay, we talk about remove, we just say this pointer move down. Let me just say move down to this. Yeah, it's not easy to type now. And what I'm going to do, I just move it here. Okay, move my arrow. So now pointer is here. Which this whole thing here is going to be garbage collection, like here. We're going to now point is going to be, which we just remove 3, and that is first in, first out. That means 3 was the first one in, and it's being removed. That's Q. Right. So let me put this thing back. But if when I add, instead of add at the bottom, if I wanted to stack, right, I want to add at the top. Every time I add at the top, it's just like stack, keep filling at the top. Like if I add 4 at the top, right? Let me actually just copy this whole set and do insert. So instead of the Q, I want to do stack. Stack is last in, first out. So you may see that once I generate a list, okay, let's say if the list first one is 3, I'm going to say, okay, 3 is there. This is the no, right? Which it might be easier to look at. I'm going to put 4 on the top, right? If I add, I put 4 on the top, right there, and then I point to that, right? And every time I have to move my pointer like that. When I remove the top. So that is stack, right? Because first in, last in, first out. Now we're going to implement stack. When I add, I want you to look at 2 things, right? I already created a node, which is 3, right? Which is now it looks like that. And empty, right? And I have the pointer pointing to it, right? It looks like that. Once I want to add a new node, it's going to call the add method again, which is going to generate a new node, right? I can always call add, it's going to do the new node, which is it's going to call the new method and make 4. And 4 is going to have something like that, null to it, right? Which is, I'm going to insert a pointer for null right there. It's going to look like that. Exactly, like our code and code look like that. We have to actually make this null, remove it, right? And this is going to point to this guy, right? Make this point to this guy instead, right? How do we do that? Very easy. In your code, first, to move that, we say new node dot set pointer to where? LL pointer, right? Because let me move that screen up again. Here, this is the LL pointer right here. This is the LL pointer, right? So I would say this new node is going to point to LL pointer. So it just looks like that now. Make sense? But if you do that, for the first element, it's going to point to itself instead of null, right? first element to the point itself. Then you only do that when it is not the first element. How do you know that it's not the first element? Then we said if it's not empty, right? That's if it's not empty. That's one way, which is pointer is not null, right? Or if it's equal to null, right? We only do this. But if it's not, then we said, hey, this is not the first one. Then we start to set a pointer, right? But we're not done yet. Why? We have to move the pointer back to the beginning list is here now, right? Correct? Then that's the starting of your pointer. So how do we do that? Pretty much just saying right here, and also, oh, by the way, we never moved the pointer. I just create a new node. I should have pointer point to it too, right? Which both of them are going to do the same. LL pointer is always equals to new node. We don't need to put in the if. Correct? Alright, so first time instantiate this list, it's going to say LL pointer is empty. Now I'm going to add something. Let's start add. And I'm going to add David. So when I'm doing that, it's going to call David right here, right? So I'm going to add David, and David is going to be passing to the add. I'm going to show this again, right? And we'll just move everything out of the way, right? Everything else away. So now, first time this is supposed to point to where? No. And when I say David, David is passing in to the new node. That's the command to create a new node and pass David in. And the pointer is null because our node set to null, right? According to our node here, pass elements, pointer equal to null. Right, so it looks like that. Then I need to move if it is empty. Yes, because LR pointer is equal to null. Then it's not going to do this. It's not going to do this when it's not empty. Then it's going to say LR pointer equals to new node. So it's moved to new node. Then we get a list with one element, David, right? If you want to test this, I add David. I can assert again. Just simple assert first. Is it empty? Assert true or assert false? It should be false, right? To pass this test, right? Because it's no longer empty, right? Run the test. If it's green, we good. It's no longer empty. It's worked so far, right? So that's how you run the unit test, right? But we will learn more when we start to remove and add the toString. Then we can test the actual values too, right? Now we're going to add more, right? When you add more, when you start to add the second element, alright, so we done with the first one. If I add the second one, if I want to add with this way, right? This is the way that we did add. We will add Edward to the list, okay? And this is supposed to point to, right? So first time when we add Edward. It's going to call new, and it's going to be an empty. Right? It's going to look like this, Edward, and also empty, like no pointer, like that. I mean no. It's going to be no. Let's look at the code again. We call add again. Yeah, let's open that unit test again. Let's create that method. I'm going to add list dot add Edward. So I'm adding Edward. Let's trace the code together. So, and comparing to the image. First line is going to call is that. That's what is created with no, right? Second time, if it is not empty, no longer empty, you have David, then it's going to do this. New node, which is that new node, set pointer, that pointer being set, right? To point to the bottom right there, to LL pointer, because this is your LL pointer, right? That's your LL pointer. And after that, it's going to move LL pointer to new node. You got your list. And if you keep adding, it's going to do the same. If you add George is going to go to the top, create a new node, right? Let's add George, right? So George is going to go to the top. And that's the new node statement. So it's empty. It is not empty, the list no longer empty. Then it's going to do this if to set the pointer to LL pointer is, which is this is LL pointer, and then move LL pointer. Alright, so that's how you add, right? You always add to the top. If you want to create a step, add to the top. Test again to make sure I can add and without no errors. So run the add. Pass again. It's no longer empty, right? But we should be able to test like what are the contents in there, right? So how do we do that? You should just create two string here, right? To return a list back. I'm going to just return string because two string, right? Pretty much just print out whatever you have in the list. Okay, two string. And this is going to be actually my, it's supposed to be what? Think about the type. It's string or E. If it's an object, you can call toString of the user too. And still return toString back here as string, right? So we can make it string because toString. Then we see everything in the list. So how do we iterate the list? We need to set a pointer from the beginning and get element until the end, which is no. So let's look at, so we initialize current, pretty much just point to our pointer, right? Pointing to the same point right there, right? Another pointer named current right there. And we're going to iterate this down and get elements until the end. So how do we do that? So while, right, current dot get pointer not equals to no, you're going to iterate, right? Which you have to do increment, right? Inside current dot current equals to current dot get pointer, get the next one.